is about systems of equations, which is you did learn in 8th grade, you did learn in Algebra 1, but it shows up a lot on the KSA. And what we're going to be doing with this is going to be a little different than how you saw it previously, probably, because we're not just doing the algebraic steps. It's really going to be heavy on like the word problems, real world problems, and setting up the equations. In the past, the KSA, when it comes to solving them, you actually most of the time have always got the Desmos calculator, and which I'll show you, it solves it for you. What really you need to know how to do, especially for KSA or whatever, is set up the equations. So that's what we're going to be focusing on this year, or this unit. So getting into it, a system is 2 or more equations. Two or more equations. Most times they have a common point. So we're specifically looking at systems of linear equations, meaning straight lines. So we're really looking for the point where the two lines cross. And that point where they cross, we call the solution to the system. So we'll talk about 3 basic scenarios. We could, and generally this is the case, when we have just 2 intersecting lines. Okay, seems simple, seems obvious. 2 intersecting lines, how many times do they cross? 1. So they have 1 solution.
So the common points are where they intersect?
It's where it intersects, and we call that the solution. So sometimes you'll have examples where there are parallel lines. What do you know about parallel lines? They don't intersect, so they don't have a solution. So this would be no solution. What's something else that you may remember about parallel lines? What about the equations of them?
They never cross.
3.14.
No.
I was close.
What about the slopes of them?
Slope.
Yep, they have the same slope. Parallel lines have the same slope. Okay. And then sometimes you may get a problem where it gives you 2 equations that look different initially, but when you graph them, you find out that it's actually the same line.
Whoa.
That would be a case of infinite solutions. If it's the exact same line, then every point's the same. So these next 3 examples, I've given you 3 different systems, groups of 2, and notice on all of them, one of them is in what we call slope-intercept form. It's y equals. The other one is not. In order for us to really compare the 2 equations to see if they're parallel, if they're the same, if they're totally different, we need them both to be in slope-intercept form. So what we're going to do is take the one that's not, In this first one, it's the bottom one. And we're going to convert it to slope-intercept form. My goal is to get the y by itself. So what step am I going to do first to get the y by itself? Add the 6x to both sides. Now in slope-intercept form, it's mx plus b. We generally write the thing with the x first. So I'm going to write 2y equals 6x plus 8. You can't, the 8 doesn't have an x, so you can't combine those. You just leave it like that. Yeah. And is the y by itself?
No.
Nope. What's with it?
2.
So how do we get rid of it? Divide. You divide everything by 2.
It always starts off so simple like this. And it gets real
So we're looking, we had one equation that was y equals 3x plus 1, and then this other one is the same thing as y equals 3x plus 4. So those two lines, those two equations, which of the three groups do you think it falls under?
Wait, how do we determine?
Okay. How do we determine that? Without the graph. We're looking to see if they're totally different, if they have the same slope, or if they're exactly the same. Well, they're not exactly the same, right?
They have this parallel.
They have one intersecting.
They're parallel because the slope is the number in front of the x, right? So if both of them have a slope of 3.
They just have different lines.
Yep. Same slope. The number in front of the x is your slope. So both of them have a slope of 3. Now, if like the first one was 3x plus 1, if the second one was 3x plus 1, that would be the same line. Okay, but this one, they have the same slope. So they are parallel. So no solution. Yep. And we could, if I told you, allowed you to graph this, you could potentially, like you would graph it and you could graph the originals and you would see that they're parallel. Because if you type this negative 6x one into Desmos, the same thing. All right, so let's do number 2. This first one is already in slope-intercept form, so the other one I'm going to change so that I can actually compare them. Because we really are checking to see if the slopes are the same and if the whole thing is the same. And we can't do that if they're not in the same form. So first step would be to subtract the 8x. And I'm going to put the negative 8x first because slope-intercept form generally have the x, whatever's with the x comes first. If you put negative 6 minus 8x, that's okay. You just have to remember where the slope is. And then what do I do? Divide by 2. And I get y equals negative 4x minus 3. How does that compare? So This 8x plus 2y, this is equivalent to y equals negative 4x minus 3.
Infinite.
Which is the exact same as the other one. So all of those are the same line. So yes, it's infinite. So same line. Infinite solutions. And then number 3, the second one this time is in slope-intercept form. Let's look at, we need to move around the first one. X plus y equals 5. What am I going to do? Subtract the x. And I get y equals negative x plus 5. And the other one that I'm comparing it to is, well, is there anything to divide by? Okay, let's go back.
What? Why did they switch it around? They messed me up.
Why? It's just because I gave, the second one was already in y equals mx plus b.
But why they wrote like this? They went like that. They switched it around. Now we're doing the one on the top. They messed me up.
We're doing the one that's not y equals.
I know, but it messed me up.
I'm gonna guess this is one solution.
So we have y equals x plus 5 and we have y equals negative x plus 5. You first need to look at the slopes. Are the slopes the same? Nope, you got a positive one and a negative one. If the slopes are different, they're just two intersecting lines. So this one is one solution. Yep.
There you go, I was right.
So now, these are probably, you'll think these are easier, actually. So we're going to look at, I'm going to give you some equations, and we're going to determine if a point is a solution. Now, if I ask if this point is a solution to this one line, I'm asking, is that point on that line? And the way to check is to plug in the x and the y and see if your equation is true. Okay. So I'm going to see if the point 3, 5 falls on this equation. Y equals 5x minus 2. So I'm going to plug in a 3 for x. I'm going to plug in a 5 for y and see if it's true. Oops, I done messed up. Y is 5, not 3.
Look at me 5y and
You put the 5 in the y spot, so the y goes away.
and then would it be 5 parentheses 3 and 3?
Over here, yes. Yep. That's what it would look like. I'm just going to do this green. So we put the 5, the y here is 5, and then I have this 5, and then x is 3 minus 2. And so then I'm left with 5 equals 15 minus 2, or 5 equals 13. Is that true?
No.
Does 5 equal 13? No. Nope. So that means that 3, 5 is not a solution. I took up too much space for that. So when you plug in the x and the y, if it does not make a true statement, then it's not a solution. So then we can try another one. y. This time I'm using the same equation, but I have a different point. So what's my y? Negative 7 equals 5. And then what's my x? Negative 1 minus 2. So I plugged in negative 1 for x, negative 7 for y.
So basically it has to equal negative 7.
Yes. Yep. So this would be negative 7 equals negative, which is negative 7. So that means negative 1, negative, oh, have mercy. Negative 7 is a solution. Now number 6, if I say, is the point a solution to the system, that would mean it would have to be true for both points. So I have to check, or both equations, I have to check the point in both equations and see if it's true for both. So we're still using 5x minus 2. So 8 equals 5, and then my x is 2 minus 2. So I'm going to see if that is true. This would be 10 minus 2, which is 8. Is that true? Yes. Okay, so we'll check the other one. Y8 equals negative, and then my x is 2 plus 10. What is negative 2 plus 10?
Why didn't you put the negative 8 too?
Because that, okay, so if my x had been a negative number, I would have had negative and then another negative. So I put that 2 in parentheses just because that 2 is going just where the x is. That negative is still outside of it. You didn't have to do it that way. But this is 8. Yeah, negative 2 plus 10 is 8. So that is true. So 2, 8 is a solution to the system. I want you to try 7, 8, and 9. So number 7, we were plugging in a negative 1 for x and a negative 4 for y. And when we did the math, we got negative 4 equals negative 4. If you get the same number on both sides, it's good. Number 8 should have been plugging in a 3 for x and a negative 1 for y. And notice it's minus, and then you also have the negative 1. So if you were to do this math, you got 6, that's plus 1. Now, if you have your calculator, you can just type this in, and it would give you 7 equals 5, which is not true. That means at that point, if I were to graph the line, 3, negative 1 is not on that line. Okay, and then
Looks like your daughter looks like you a lot.
thanks. All right.
Well, I was thinking about her being in the.
Oh, okay.
Number 9, yeah. So we had a system, which just meant we had to check both of them. And 2, 8 worked for the first one, but it did not work for the second line. So that meant it was not a solution to the system.